So we're going to be talking about writing ratios. Now we really need to know what a ratio is first, so a definition is a good place to start. So a ratio is a comparison of two or more amounts. It's a great way of comparing things. Let's look at a bag of marbles. Alright, so here's our bag of marbles. You can see we've got 4 kinds of marbles here, and we're going to do what's called some part-part ratios. So here's my first example. I'm going to find the ratio of striped marbles to solid marbles. Alright, the ratio of striped marbles to solid marbles. I have 2 striped marbles and I have 3 solid marbles. The ratio is 2 to 3. We say that as 2 or 2 is to 3. Now you can always turn a ratio around. So if we're doing solid to stripe, this time it's going to be 3 solids to 2 stripes. Obviously when you're writing them, it's important that you write them in the correct order. Now, our definition says that it's a ratio comparison of 2 or more amounts. So we can do a ratio of 3 here. Solid to cross to blank. Alright, solids, there's 3 of those, is to 4 of those, is to 6 of the blanks. 3 is to 4 is to 6. So this is the first time we might have to think here. So we've got our cross and our stripe here. 4 crosses to 2 stripes. Alright, so it says there's 4 of those and 2 of those, but when we're talking about ratios, we can simplify those ratios. So looking here, we have a highest common factor of 2, therefore we can divide both of these by 2. And if we divide both of those by 2, we get 2 is to 1. So the ratio of this to this in simplest form is 2 is to 1. What that means, physically, we say, alright, there's 2 of those for every 1 of those. There's 2 of those for every 1 of those. That's how a ratio works. Now you probably understand all of that, but the one thing you're probably still asking is, why are they called part-part ratios? Well, the easiest way to show you that is to show you the other kind. Part-whole ratios. Now part-whole ratios are a ratio between one of these types of marbles and the whole amount of marbles. Part-whole. Whereas this is part-part, because this is the whole, and we're just comparing one part to another part. So let's do a part-whole ratio. So here's our part-whole ratio, the open ones to all marbles, or the blanks to all marbles. So we can see that there are 6 blanks, and there are 15 total. And you should be looking at that and saying, oh, you can simplify that because there is a highest common factor there of 3. So I can divide both by 3, and when I do that, I'll get 2 is to 5. Now that's really, really useful, that ratio, that part-whole ratio. There's a couple of things you can do with those ratios that make a bit of sense. If you've got a ratio like that between 2 things, you can convert the ratio to a fraction. Alright, so if I've got 2 is to 5, it's really easy to write that as a fraction. This goes on the top, this goes on the bottom. Numerator, denominator. 2 over 5. Now what does a fraction of 2 over 5 here represent? Well, if we look at this one here, what that says is 2/5 of all of those marbles are blank. It tells you the fraction of the marbles that are of that whole. 2/5 of the marbles are blank. Now, if you can do a fraction, you can do a decimal, you can do a percentage. So if you'd like to convert it to a decimal, 2/5 as a decimal, you can just type 2 divided by 5 into your calculator and you'll get 0.4. Now, 0.4 doesn't mean a lot to me as a decimal, but it would mean quite a bit as a percentage. So if we convert 0.4, which is 2/5, which is 2 to 5, to a percentage, we would get 0.4 and then multiply that by 100, and we would get, you can think of it as moving the decimal 2 places, or you can think of it as moving the number 2 places. Either way, we're going to get 40%. Now that means 40% of all of the marbles are blank. Alright, we've covered a lot of stuff here. This is just the introduction to ratios, learning a little bit of stuff, revising a little bit of stuff. We're going to do a lot more in a few videos.